Hi everyone, this is your teacher Justina and telling you to do subscribe me if you are still new on my channel. And do not forget to like and hit the notification bell for more updates. Our video for today is all about derivatives. What is derivative? Suppose you are given a curve and on the curve there are tangent lines on it. Suppose you are asked to determine the slope of each line. How is derivative being defined out of these illustrations? How many points we need to know in order to have the slope of a line? Okay, I just remember that we need to determine or choose two points rather from a line to determine the slope. Thus, you are given the 2 points already have chosen, and for this to determine the slope, we need to determine the rise in the run. So from this point, going to this point is simply going 4 up and going right 4 units, and that is represented by 4 over 4, or our slope is equal to 1. How to determine the slope of the tangent lines if we only know 1 point from it? Because as you have seen, the line on the right, it has 2 points, and thus the slope is 4 over 4. We have the rise in the run, but the question is, how do we find 2 points out of the lines that are touching to the curve? Okay, let us explore this. Okay, let us have this illustration. A Cartesian plane with a curve and 2 points on it. Okay, we will be naming the point by this following units. So, from that point, this is from the 0, and this is represented by x units. This one. And for that, we will be going to the second point, and this is from x going in here. We were able to add h units, so naming the point is x plus h because we already added an h unit. Then that will be named as x comma f of x, and the point 1 is being represented by that particular point. So if we have our point 1, thus, our x sub 1 and y sub 1 already represented by the following coordinates. And then for the second point, we will be naming it. Remember that this point is made up of from this particular distance. This is x plus h units represented by our x coordinate, and our y coordinate is represented by the vertical distance and represented by f of x plus h. So, if that's the case, we have already our point 2. If we have our point 2, thus we have our x sub 2 and our y sub 2. And we're able to connect the 2 points. So connecting the 2 points, I'm sure you remember a certain line that intersects a curve at exactly 2 points is what we call the secant line. But our focus is to determine the slope of the tangent line tangent to a curve. So, how do we relate the secant line to the slope of the tangent line? Okay, so remember that if we are going to get the slope of a line, we have to consider 2 points. So the 2 points are already given, the point 1 and point 2. So we just substitute it. So our y sub 2 is already represented by f of x plus h, and the y sub 1 is already the f of x, and our x sub 2 is already x plus h as you have seen in here, and our x sub 1 is already an x in here, our x sub 1. Okay, and for that, we need to simplify the positive x and the negative x, and for that, we can now cancel, or it will sum up to 0, positive x minus x. So therefore, the remaining denominator is already an h. Okay, And what do you call this remaining expression or the resulting expression? That is what we call the slope of the second line. So if that is the slope of the second line, are we gonna discover as to how to get the slope of the tangent line? Okay, so far, this expression, this remaining expression is said to be the slope of the second line. This is said to be difference quotient because difference and then quotient because it is expressed in division. Now, I would like you to observe what will happen if this line will be moving towards x. So if ever this line will be moving in here until such it will be getting closer and closer and closer to that particular point. What do you observe? From the second line, what do you call the line as it is moving towards H, as it is getting closer and closer to X? So for that, let us now have this next illustration. So I'm sure you remember that our point is from here. It is now being into this uh, illustration already. So from the 2 points, which is from here, the point is getting closer and closer and closer and closer until such from second line, it is now a tangent line. Again, from a second line, it is already a tangent line. So therefore, if it is already a tangent line, thus, from the formula, from the second line, it is now uh, heading towards H. So therefore, from this formula, as the limit approaching to H and H approaching to 0, this will be then the so-called the definition of the derivatives. So what do you mean by derivatives? So of course, as you still remember the slide before, it's all coming from the slope of the second line until to the slope of the tangent line. So this expression is said to be the definition of the derivatives. So if that is the definition of the derivatives, how do we express it into the correct notation? So the definition of derivative is being represented by this expression f prime of x. This is said to be as f prime of x, or the derivative of f is equal to f of x plus h minus f of x over h as the limit h approaching to 0. But the question is, what is the use of this formula in such a way that we will be getting the slope of the tangent line? Again, this expression defines the derivatives. Let us try use this formula. The slope of the second line becomes the slope of the tangent line. So that is what we did in the previous slide. Okay, so let us now go to the the definition of the derivative. So far, when we say derivative, it is a function that tells you the slope of the line tangent to the curve at any point. It gives you the rate of change. So when we say rate of change, it talks about the slope. It gives you the rate of change at any point on your curve. So steepness or rise over run, it's the slope. So when we say derivative, it is simply uh, concerning the slope of the tangent line. It is the slope of the tangent line to the curve. So a tangent line is a line that touches at only one point on the curve. So again, let us have to highlight when we say derivative, it is a new function that gives the instantaneous rate of change at each point of the old function. So when we say instantaneous rate of its change at its point of the old function, so again, it's just simply a slope of the tangent line. Let's consider this example. Given a function of f is equal to 4x squared minus 5, and then we will copy the 4x squared, but instead of copying x, we have to substitute it by x plus h, and then continue writing minus 5 because instead of 4x squared, we have 4 times x plus its quantity squared, and then minus f of x. When we say f of x, our function of f itself, and it is represented by 4x squared minus 5. And then let's proceed to simplifying the x plus h, or in other words, uh, expanding the square of a binomial. So this will be x squared plus 2xh plus the square of h, and then minus 5. Then distribute the negative. This will become negative 4x squared plus 5. And in the formula, there is the denominator of h. And then let's proceed to the distribution. We will be distributing that 4x squared plus 8xh plus 4h squared minus 5 minus 4x squared plus 5, and this is over h. And we will just write this notation limit as h approaching to 0 later. Now let's proceed to combining like terms. The 4x squared and the negative 4x squared will sum up to 0. The negative 5 and the positive 5 will also give you a sum of 0. Thus the remaining terms are the 8xh plus 4h squared over the denominator h. And for this, as the limit as h approaching to 0, the 8xh plus 4h squared over h, the 8 and the 4, of course, the common is 4, and there is an h in here and an h in here. Thus, we have 4h is our common monomial factor. So this will be already 2x and then plus h, because 4h squared divided by 4h will give you an h already. And this will be over h. And please try see that the h in the numerator and the h in the denominator are common. Thus, we will give you a quotient of 1. So the remaining term is 4 times 2x is 8x plus 4h. And since as the limit as h approaching to 0, so therefore, instead of having 8x plus 4h, we have 8x plus 4 times 0. And thus, our derivative will be 8x as h approaching to 0. And what is this? This is already our new function, or in other words, this is the derivative of the old function f of x is equal to 4x squared minus 5. Guys, I just wanna recommend you to see my next video as part 2 of this topic. Goodbye and thank you for watching.